Hello, everybody. So we are getting into 4.3 today, solve multi-step inequalities. All right, the last couple sections have been focusing on just inequalities themselves and, solving some of them, but this is getting into multi-step. So if you've been feeling good so far, this is going to be a little bit more of the same, just, I guess, more complicated problems to dig into. All right, so go ahead, take a minute, go ahead and get the title at the top, copy down this example. We'll try this one again. Okay, so on this example here, they want us to solve the inequality, and they want us to then graph the inequality. All right, so let's go ahead and do it. First thing I notice, we have a 3 on the outside of parentheses, and whenever you see distribution, that's normally where you'll start. So let's go ahead and distribute that 3 into the parentheses. So 3 times negative w is going to give me a negative 3w. 3 times 12 is going to give me a positive 36. Over on the right here, nothing to change the inequality sign, nothing to flip it yet, and we have a 0 on the right. Okay, from here, now we can just go ahead and solve. So I have this 36 I can get rid of first by subtracting from both sides. All right, always a question to have is, I just subtracted a number. Does that mean I need to flip the inequality? No, if you guys remember, that's not the rule for flipping. Doesn't matter if we add or subtract numbers to both sides. Okay, so that's staying the same. We have a negative 36 on the left. All right, and now I can get rid of this negative 3. It's being multiplied, so I'm going to divide. All right, here's the question. I just divided by a negative 3. Should I flip my inequality? Hopefully you're thinking, yes, Mr. Stone, you just divided by a negative number, and that is when we need to flip an inequality. All right, just I want to point out again, if this had been a positive 3 and I divided both sides by a positive 3, I would not have flipped that inequality. Okay, it's when it's a negative number and you're multiplying or dividing. So on the left, they're gone. We got W, and this double negative is going to turn into a positive, and 3 is going to go into 36, 12 times? Okay, and there we have it. Now we can go ahead and graph this real quick. Go ahead and draw yourself a number line. I keep shifting that, it's annoying. There we go. So yeah, there's my number line. I always put that number we're dealing with in the center, surrounded by some numbers left and right. So 12, 13, 14, 12, 11, 10. All right, and hopefully you're feeling good by graphing by now. Here's what I noticed. We do not have an equal to symbol, so this is not a closed dot. It is an open dot. It is greater than, and that is an arrow that goes to the right where all of the numbers are getting greater than. All right, and put a little box around your answers. Cool. So let's go ahead and move along here. I'm going to have you guys try one a lot like that problem. So go ahead, solve this thing, graph it, see what happens. All right, so just like the other, let's start by distributing the 7 into the parentheses. Okay, 7 times negative r gives me a negative 7r. 7 times negative 3, negative 21. All right, greater than or equal to symbol does not change, have a negative 14. One thing to point out, if you look at this symbol here and you don't automatically think, oh, greater than or equal to, if you don't know these symbols by heart yet, that's okay. Just have your other notes in front of you where you copy the names of them so you can start memorizing them. It'll just make your life easier once you do get to that point. All right, so solving this thing for r, dealing with addition or subtraction first. I'm going to add 21 to both sides. All right, so bringing down the negative 7r. I added a number, doesn't mean we're going to be flipping a sign. Negative 14 plus 21, remember, you can think of this as just 21 minus 14, which gives you a positive 7. All right, and from here, now I can solve for r. It's being multiplied by negative 7, so I'm going to divide by negative 7. All right, here's the first thing. I just divided by a negative number. I'm going to flip my inequality before I do anything else because it's so easy to forget. All right, so those are gone. I have r. Over on the right, 7 divided by negative 7 gives me a negative 1. All right, and let's go ahead and get our graph on this thing. If you haven't, do along with me. All right, so negative 1 in the center. That means be careful when we get into the negatives. As I go to the right and numbers are getting bigger, negative 1, I would have a 0 and then a 1, right? Getting smaller, I'd have a negative 2 and a negative 3. Okay, be careful with the negatives there. It's easy to kind of get that mixed up. All right, so we have an equal to symbol. We know that means we have a closed dot on our graph. and it is a less than or equal to, that means our arrow is going to the left where all the numbers are getting less than. Okay, so let's keep going. It just kind of blossoms from there. We're going to have a little bit more complicated problems. So let's go ahead and copy this one down, and we'll try this together. Okay, so just like when we had equations, it looks like we have variables on both sides of our inequality. We're going to do the same thing we'd always do. We're going to get them to the same side. Just a little reminder, I can bring the 2x over to the left, or I can bring the 6x over to the right. It doesn't matter what you choose. I like positive numbers, as I always say. So I'm going to take this this 2x, and I'm going to subtract it over to the left because I like that that's going to give me a positive 4x. All right. Yeah, so bringing down the -7, I just subtracted something, so no reason to flip the inequality. Over on the right, looks like we just have 17. Okay, so now we can go ahead and solve this thing. And if you're kind of looking ahead here, you might notice we're going to end up with a fraction, and that's sort of what the point of this problem. So let's see what happens. So actually, are we going to end up with a fraction? Actually, I don't know. I don't know. But let's see what happens. So adding 7 to both sides, looks like we're going to get 4x on the left. I added a number, so no reason to flip the inequality. So I have that. And then I'm getting a 24 on the right. And I said we were going to have a fraction, but I was wrong. Good old Mr. Stone. So yeah, when we go to divide here, first things first, I divided by a number. Should I flip my inequality? No, because it's not a negative number. So this thing is still saying greater than, and it looks like we're going to be getting an x and a 6 over here. Okay, so another clean answer, though it is possible to get fractions on these. I'll just point that out, but it didn't happen this time. So there's our answer, and let's go ahead and graph it real quick. All right, so number line, we've got a 6 in the center. That means 7 and 8, 6, 5, 4. All right, no equal to symbol, so open circle. X is greater than 6, so the number is greater than 6. Right, so again, this graph represents all of the answers that is possible. You know, any answer greater than 6 could be what x equals, but not 6. And that's, again, why we put this open circle and not a filled-in circle. The circle would represent that 6 would also be a possible answer, but it's not. All right, let's have you guys go ahead and try one of these on your own. Same directions. You don't need to keep getting those. Copy it out, solve it, see what happens. Alrighty, so variables on both sides, you can bring them to one side or the other. Just for the sake of it, I'm going to bring this -3y. I'm going to add it over to the left-hand side. You might have added the 6y to the right. That's okay. It's going to look a little different as we go through it, but we should end up with the exact same answer. So I'm going to add a 3y over to the left. -6y plus 3y is going to get a -3y. Okay. Bring down the +5. I just added, so no reason to flip the inequality. -16 on the right. Okay, so solving this thing, first let's get rid of the 5. -3y. I subtracted a number, no reason to flip the inequality. And combining these negatives, remember, you know, we get a bigger negative when we combine these, so we get -21. And now we can go ahead and divide by a -3. And here's the first thing I need to remember, just divide it by a negative number. Let's remember to flip the inequality. Okay, so I'm getting y is greater than or equal to a +7. No matter which way you did this problem, you should have also got that answer. Okay, if you didn't, by the way, hop into the Google Meet, ask me questions. Okay, so we have a 7, let's see, 8, 9, 7, 6, 5. Okay, equal to symbol, close dot. Oop, let me make it red. And greater than, that is to the right where all the numbers are getting bigger. Okay, so we got a couple more. Let's keep going. Okay, so the directions on these are changing the pace a little bit. These are saying solve the inequality if possible. All right, if you see the words if possible in directions, that means you might not get just a typical, you know, answer. You might have to think a little deeper, I guess. So let's take a look at it. So I guess go ahead, copy this, and we'll try it out. All right, so you know quite a bit here. First thing, I see distribution. Let's deal with that first. All right, so I'm just going to bring this down on the left. 14x plus 5 less than 7 times 2x is a 14x. 7 times negative 3, negative 21. Okay, so now this looks a lot like the problems we were just doing the last couple slides. Let's go ahead and get our variables to the same side. You can kind of see what's going to happen here. If I take this 14x and subtract it over to the left here, okay, 14x minus 14x, those are actually canceling, and I have a 5 on the left. Okay, my symbol does not change, right? Just subtracted. Over here, again, those also cancel. I'm having negative 21 on the right. Okay, we saw this when we were doing equations, and if you guys remember, when we got to this point where we eliminated variables, we always asked ourselves, does this make sense? Okay, when it made sense, we would give it a certain answer. When it didn't make sense, we would give it a different answer. All right, so let's see what happens here. This is saying that 5 is less than negative 21. Is that true? Does that make sense? I would say no, it does not. Okay, so I don't know if you want to put a little no next to it. That's not our answer. Okay, or sometimes people will put a little cross through that, meaning it does not make sense. However you want to represent it, I don't really care. But we need to realize, since this does not make sense, the answer to our question is going to be no solution. Okay, and if you guys remember, what that means is there is no value for x that we could plug in to make this inequality work. Okay, no solution. And the reason why we picked no solution was because this did not make sense. All right, let's try another. Okay, same directions. You don't need those again. Go ahead, copy this down. We'll try it together. All right, so looks like we have some like terms on the right. I would probably start by combining those. So let's bring down this 3p minus 5 greater than 2p plus 1p gives me a 3p. You can probably see where this is going. Okay, so variables on both sides, let's go ahead and bring them to the same side. I'm going to subtract 3p over to the left. And just like the last problem, yep, these are canceling. We have a negative 5 over here. These are canceling. We have a negative 7. So we kind of run into the same thing, and we ask ourselves the same question. Does this make sense? Is negative 5 greater than negative 7? Okay, be careful on this. The negatives make it a little confusing. Would you rather have someone take $5 away from you or $7 away from you? Okay, so, negative 5, yes, is greater than negative 7. So this does make sense. Sometimes I like to put a little check mark, or if you want to say yes, it does. Okay, but really, our answer is, since this makes sense, our answer is all real numbers. Okay, you can just use a little number sign. Okay, that is our answer. And what that means is all numbers, all real numbers, which we only deal with real numbers in this class, any number we plug in for p would be an answer to this inequality, would make it make sense. Okay, so when it does make sense, your answer is all real numbers. When it does not make sense, your answer is no solution. Okay, so last thing, I'm going to have you guys try one on your own. Go ahead, copy this problem and see what happens. All right, so distributing our 6 into the parentheses, looks like we have a 12x minus 1 is greater than a 12x minus 6. All right, just to kind of get through the, what's going to happen here, I bring my variables to the same side. Just so happens on this problem, they cancel out. Just remember, it doesn't always happen like that, right? But that's kind of the point of these. So they're canceling. I have a negative 1 is greater than negative 6. All right, so here's the question. Does that make sense? What do you think? Okay, negative 1, is it greater than negative 6? Yes, it is. This does make sense. Okay, so since it makes sense, your answer would be all real numbers. Okay, every number possible we could plug in for x and it would work. All right, so yeah, there's a little bit more on solving inequalities and graphing them. Hopefully you're starting to feel comfortable on this, because this is a lot of the same math we've been doing for a while. All right, so yeah, let me know if you have any questions, and I'll see you guys in a bit. Bye.